In the previous section, we talked about solving a system of linear equations using the graphing method. In this section, we will talk about solving a system of linear equations using the substitution method. So, how do you solve a system of equations using the substitution method? So step number one, solve one of the equations for one of the variables. Now that sounds kind of arbitrary, but we want to avoid fractions here. So what we want to do is we want to solve for the variable with a coefficient of 1. For example, let's say we have x plus 3y equals to 6. The coefficient of x is 1, and the coefficient of y is 3. So here, this is the coefficient, which is 3, and this is the coefficient, which is 1. So the variable we would solve for is, in this case, you would solve for x. Okay, so in this case, you would solve for x. Another example, let's say that we have 3x plus y equals to 6. In this case, the coefficient of x is 3, and the coefficient of y is 1. So then we would solve for y, because we always want to solve for the variable with a coefficient of 1. Okay, so always solve for that variable that has a coefficient of 1. Now from there, I'll take you guys through the steps as we do problems. So we want to solve the following system of equations. We have x plus y equal to 54, and we have y equal to 5x. Now step one, it says solve one of the equations for one of the variables. Now in this case, this variable is already by itself. We already have y equal to 5x. Y is by itself. So step one is done. That is step one, where we get the variable by itself. And since that's done for us, step one is done for us. Now let's go to step number 2. Step 2 says substitute the expression solved for in step 1. So this expression y equals 5x into the other equation. So you can't plug it into itself, because then you go in a circle. So we take that y equal to 5x, and in the other equation, we're going to replace the y with a 5x. So the result will be a single linear equation in one variable. One variable means there will be all x's or all y's. So now we take our first equation, which is x plus y equal to 54, but notice that y is equal to 5x. So what we're going to do is, instead of y, we're going to replace the y with a 5x. And what that allows us to do is we get this equation with all one variable. See, it says an equation in one variable. These are all x's. Step 3 is we now solve this. So step 3, we solve this equation. X plus 5x is 6x if we combine our like terms. And then the opposite of multiplying by 6 is to divide by 6. And this gives us x equals to positive 9. That's our x value. Step 4 is we take that x value and you plug it into any of these equations. Doesn't matter which one you plug it into. I'm going to plug it into the equation from step 1, which is y equals to 5x. So since x is 9, we're going to get y equal to 5 times 9, which is 45. So my solution, and my solution is always written as an ordered pair xy. So my solution is going to be the point 9, 45. And once again, your solution always has to be an ordered pair, where you write that in parentheses, x, y. And if you'd like, you can also check your answer, which I recommend for quizzes and exams. Let's take a look at the second one. Second example, we have negative 4x minus 7y equals to negative 41, and we have x equal to 5y minus 37. Now remember, step 1 is solve one of the equations for one of the variables, so get one variable by itself. We already have that. We already have x equal to 5y minus 37. So step 1 is done. That's step 1. It's done for us. So now all we have to do is we now have to go to step 2. Now in step 2, we take that variable that's by itself and you plug it into the other equation. So in the other equation, which is negative 4x minus 7y equals to negative 41, I'm not going to write negative 4x. I'm going to replace x with what it equals to, which is going to be 5y minus 37. And then I still have a negative 7y, and that equals to negative 41. Then I'm going to distribute this. So I'm going to get negative 4 times negative 5. That's going to be a negative 20y. And then I have a 37 times 4, which is going to be 148. Remember that a negative times a negative is a positive, so that gives me a positive 148. And then I have a minus 7y, and that equals to a negative 41. Then I combine my like terms, so I have a negative 20 and a negative 7. So negative 20 and negative 7, this gives me a negative 27y plus 148 equals to negative 41. Okay, if I keep going from there, so the opposite of adding 148 is going to be subtracting 148, so I subtract 148 from each side. And I'm going to get negative 27y equals to negative 189. If I divide both sides by negative 27, I don't have a calculator. I think 27 times 9 is 189. I should have been prepared with the calculator near me, but let's check it out. 9 times 7 is 63, carry over the 6. 9 times 2 is 18, plus 6 is... Nope, that's too much. So let's try... Seven. 27 times 7. 7 times 7 is 49. Carry over the 4. 7 times 2 is 14. Okay, perfect. So this goes in 7 times. So we have a negative divided by negative, which means that we're going to get y equals to a positive 7. Okay, because again, a negative times a negative is a positive. But we're not quite done yet. Once we find y, we still have to find... So this was step 3 when we solved it. And in step 4, we know that y is equal to 7, but we still have to find the value of x. We still got to find the value of x. So to find the value of x, you have two equations, equation 1 and 2. I'm going to use the second equation because it's easier, which is 5y minus 37. And if you use the first equation, you would get the exact same answer. It doesn't matter which one you use. So we have x equals to 5y minus 37. All right, now y is 7, so it's going to be 5 times 7 minus 37. 5 times 7 is 35, and 35 minus 37 is equal to negative 2. We always write the answer as an x and a y coordinate. So my x coordinate is negative 2, my y coordinate is positive 7, and that is my solution. Of course, you should always go back and plug it in to make sure that this is correct. The third equation, x plus 3y equals to 7 and negative 2x plus 5y equals to 19, we will save this one for class. Let's take a look at the last one. It says an admission fee at an amusement park is $1.5 for children and $4 for adults. On a certain day, 296 people entered the park, and the admission fees collected totaled $744. How many children and how many adults were admitted? So for this problem, we have to set up two different equations, one equation for the money and one equation for the number of people. So first, let's take a look at what are we looking for. We're looking for how many children, so let's call the number of children x, and how many adults, which is we'll call y. Anytime you do any kind of word problem, you always have to identify what we're looking for, and those are your variables. So we're looking for the number of children, and we're looking for the number of adults. Now here's what I know. I know that 296 people entered the park. So if I add the number of children plus the number of adults, that gives me 296. Now children, it costs $1.5. So for the money, I'm going to multiply the number of children that entered times 1.5, and adults cost $4. So I'm going to say the money we collect from adults is 4y, and then this is going to equal to the total amount of money collected is 744, so this equals to 744. So what we have here is we have two equations. One equation for the number of people, so we have 296 people, and then we have one equation for the number of for the amount of money collected. So we collect $1.5 for every kid, which is why we have 1.5x, and then we collect $4 for every adult, which is why we have 4y, and that equals to 744. So that is going to be the setup. Now what we're going to do is we're going to solve this equation using substitution. So step one, sorry about that. Step one is to get one variable by itself. And remember, you always choose a variable that has a coefficient of 1. So I can just go with this x. So I have x plus y equals to 296. And if I want to get the x by itself, I'm going to subtract y from each side. So what's going to happen is I'm going to get an equation that says x equals to 296 minus y. That's my new equation. That's step one. Step two is I take that and I plug it in, not to that same equation, because then I go in a circle, but into the other equation. So my other equation is 1.5x plus 4y equals to 744. But instead of x, I'm going to replace that with 296 minus y in parentheses. So I have 1.5, but instead of x, I'm going to replace what x equals to, which is 296 minus y. And then I still have the plus 4y, and then I have this equals to 744. And now I have to solve this equation. So if I distribute this, I get 1.5 times 296, which is 444, minus 1.5 times y, which is 1.5y, plus 4y equals to 744. I combine my like terms. So if I take negative 1.5 plus 4y, that's going to be 2.5y. And feel free to use a calculator, put negative 1.5 plus 4, that'll give you 2.5y equals to 744. And then I subtract 744 from each, or sorry, subtract 444 from each side because I want to get that 2y by itself. So then over here, I'm going to get 2.5y equals to 300. And then lastly, if I divide both sides by 2.5, I'm going to get y equals to 120. So I guess that's like steps 2 and 3 combined together. Step 3 is where I solved it. Now once I get y equal to 120, I need to go back in step 4 and solve for x. So the easiest equation to use will be, you can use the first equation, or you can use this equation where the x is already by itself, which is 296 minus y. And then so x will be 296 minus 120, which will equal to 176. So since x and y aren't just numbers that represent something, we have to write a sentence using this. So x represents, and this is why it's important in the beginning to label what x and y are. X represents a number of children and y represents a number of adults. So we're going to say that 176 children and y is a number of adults, and 120 adults were admitted to the park. And this will be your final answer. All right, as always, come to class prepared with questions, and I'll be happy to go over them with you.